One of the greatest telecommunication companies in Kenya is Safaricom. And Safaricom, one thing very interesting when you work with or for Safaricom is that they choose to give you their own laptop. They choose to buy for your laptop rather than you buying for yourself a laptop. And of course, that's because of security measures. And the reason why Safaricom will choose to give you their own laptop is because those laptops come already installed with a VPN, and they can always, monitor the activities of your device. And you might not be able to install or uninstall any applications without their permission. All right. And so they use a VPN. I think a Safaricom telecommunications company, which is one of the greatest in Eastern Africa, they use VPNs from Cisco. They use a VPNs from Cisco, and which does a very good job. So for this part here, we'll explain how VPNs, and we'll learn of a special type of VPN called IP security VPNs and how it is used to secure site-to-site and remote access connectivity. So we'll look at the benefit of a VPN technology, then we'll describe the different types of VPNs, and then we'll finally explain how the IP security framework or VPN is used to secure connections. Now, the VPN technology is a very interesting topology, and one of the major things that it does is that it creates an end-to-end private network connections. Okay, so a VPN, just from its name, is actually a virtual circuit, and it carries information in a very secure manner over the public internet. So it's not easy to hack into it because of some of the encryption and authentication mechanisms that we are going to talk about. Okay, so traffic is always encrypted, and looking at the diagram we see here, realize that we have this main site here, main organization. This is the headquarters here. And there exists a corporate, there's a firewall, the Cisco Adaptive Security Appliance firewall here. And there are guys here that work within a branch here using a Cisco router. And the Cisco router is normally able to be configured, by the way, with a VPN. There's a regional office, which is also a firewall, which can be configured with a VPN. There's a SOHO network here, a small office, home office network, where this is when someone is obviously working from home. And within the Cisco router is also installed with a VPN. And there's a remote worker here. And this is what Safaricom does for its employees when they're working offline. They are installed with the Cisco's VPN called AnyConnect application, which actually provides VPN services. Okay. Now, current or modern VPNs currently support encryption features, and one of those encryption features is the IP security and the SSL, and SSL, which means secure socket layer. And these are types of VPNs. And so the SSL was actually a technology that is being done away with because it's being replaced by what's called the TLS, the transport layer security. Okay. And both of these VPNs, either it's SSL VPNs or the IP security VPNs, they are both used to secure traffic between sites. But there does exist many advantages or benefits of using VPNs. And one of those benefits, as we had already seen, of course, is the cost savings, the cost element. Remember, every organization wants to have some change remaining. You want to invest and remain with some money for you so that you get some profit. You need profit that is higher than the expenditure. And so organizations will always use VPNs to reduce their connectivity options while simultaneously increasing remote connection bandwidth. Of course, they are secure because of the encryption and authentications for their users. In terms of scalability, VPNs allows organizations to use the internet, and they can add as many users as possible within their VPNs. they are very compatible with most of the connectivity options, and that's one of advantages that VPN has for us. Like I had mentioned, two types of VPNs: remote access VPN, and this is whereby, of course, we have mobile users which must have an application installed on your laptop or on your phone. And the other type is the remote access VPN, and this is a VPN that is normally implemented within the router. Okay, so long as you are connected, that router, which is can be your default gateway, then you are actually protected. Okay. Now, VPNs can be created in either using IP security or the SSL VPNs. And this brings us to what we call either a clientless VPN connection, where the connection is done using the browser. All right. So when you see SSL here, you must be thinking about HTTPS. All right. Because protocols like SSL and TLS, they're the ones that make HTTPS to be more secure than HTTP. And so the clientless VPN is a VPN that its connection is normally secured using the web browser. All right. Then the client-based VPN connection, and by the way, and this is going to divide either the IP security or the SSL. So the client VPN, an example is the clientless VPN, an example is the SSL VPN. And then the client-based VPN, the client-based VPN is actually one that requires a client software. And an example I gave you was the Cisco AnyConnect, is one of the secure mobility client software, which must be installed either on your mobile phone or on your laptop or on a desktop computer. So every time you want to use the VPN, you must actually log into using your username and password, the credentials. You must log into that VPN when you're using a client-based VPN connection. So looking at the diagram we have here, we realize that this is a client-based VPN. You can see it's actually this is the client-based here. This is the client-based here, because the laptop or the tablet must be installed with the application. But the SSL VPN, the clientless, you just need a browser and that's it. Any device that has a browser. And so at this point in time, we want to look at the difference between the two of them. Okay, the difference between the SSL VPNs and the IP security VPNs. Okay, now to note that the SSL VPN normally uses PKI, which is a public key infrastructure. Okay, and it also uses digital certificates to authenticate the peers. Okay, now this table is going to summarize for us these two technologies. And looking at the table here, we are going to make a comparison of them in terms of the application supported, in terms of the authentication length, encryption strength, connection complexity, even the connection options. Okay. And so to start us off, let's look at these differences, and we'll start with the application supported. Okay. Let's talk about in terms of the application supported for IP security VPN. Remember, this is the one that uses a client software. All IP-based applications will actually work, so it's a bit extensive. But for the SSL VPNs, only devices that have a web browser will be supported. All right, or a web sharing application for that matter, file sharing. Then in terms of the authentication strength, the IP security has a two-way authentication with shared keys or digital certificates, while the SSL one has a one-way or two-way authentication. It's a bit moderate. In terms of the encryption strength, the key lengths in IP security are a bit stronger, between 56 to 256 bits of encryption, okay? While that of the SSL has a moderate to strong encryption from 40 to 56 bits of encryption. All right. Then, in terms of the connection complexity, the IP security VPNs requires a VPN client installed on your device, but the SSL VPN only requires a web browser on a host. Okay. Then the connection options. For the connection options, we have the IP security VPN is limited because only devices with that particular application will be used. But for the SSL VPN, it's a bit extensive because any device with a web browser will definitely be able to connect. So that is something that is obviously noting. Okay. Now, in terms of the site-to-site, clearly you can see the site-to-site VPN. Normally, you have a gateway here. So this organization has the main branch here, and it has a branch location. And maybe this can be in one city, and this is in another city. And so there's a VPN connected to, and it's always configured on the router and the firewall, okay? And so the client normally connecting to this network, they don't have to use any credentials to log into the VPN. And that's why they have no knowledge that they're actually using a VPN, because any traffic they generate will go to the router, then the router will encrypt that traffic to the firewall on the VPN gateway, okay? And of course, we already saw the site, the remote access one, which does the opposite. You must have the application installed on your device. We have what we call the GRE over IP security. Now, GRE was actually one of the protocols. It's actually a Cisco proprietary protocol for configuring non-secure VPNs, and that is something for you to note. GRE, the generic routing encapsulation, is normally a non-secure site-to-site VPN tunneling protocol. But for you to secure VPN, you must combine VPN with IP security. So to encapsulate and secure the traffic within GRE, you must add it to the IP security to be able to make it more secure. So it will be something like this. We need to carry traffic from the branch router to the HQ router, and there's a GRE, configured on the two of them on virtual circuits. So if they need to exchange any OSPF routing information in a secure manner, then looking here, of course, we have the original packet in green inside there. Then in brown, we have the tunnel. The GRE tunnel is the brown one, the second one. Then the blue one will be IP security VPN to be able to encapsulate and secure that particular communication. So that is our what's called the GRE over IP security. Okay. We also have what's called the DMVPN, the dynamic multipoint VPNs. This is another site-to-site IP security VPN and GRE over IP security. And this particular protocol, which is also a Cisco proprietary solution, provides multiple VPNs in very easy, dynamic, and scalable manner. And so it simplifies the implementation of VPN tunnels and provides a very flexible option to connect central sites to its branches, okay? Now, if you remember the hub and spoke topology, it's normally used by the DMVPN, and it uses also the full mesh topology, okay? This one is very secure, and each site is normally configured using multi-point GRE, the MGRE, which is basically a tunnel interface which allows single GRE interfaces to support multiple IP security tunnels. So that is a DMVPN. Now, talking about IP security, and this is the last thing we talk about, and then we get going. IP security technologies is an IETF, Internet Engineering Task Force standard, which defines how VPNs can be secured across a public IP network. Okay, so it will normally protect and authenticate packets between a source device and a destination device, and that is providing security. So 4 elements here. We have confidentiality, which we have talked about before. Confidentiality is normally ensured using encryption algorithms, okay? And this is to prevent cyber criminals from accessing or reading any packets as they're being transmitted over the internet, okay? Okay. So confidentiality, please mark confidentiality. Confidentiality is always ensured using encryption algorithms. And encryption is the process of, and encryption ensures that only, confidentiality ensures that only authorized users can have access to information. Then we have integrity, which is always ensured using hashing algorithms. And integrity is basically ensuring that information passing from a source to a destination is not changed or it's not altered in any manner. And then we have origin authentication. Origin authentication uses a key, an internet key exchange, IKE protocol, to authenticate the source and the destination. So what you want to do is that you want to guarantee that the information comes from where it says it comes from. We have to authenticate the origin, that the sender is actually the person that we are told is sending, or what the packet says it's sending. Then in terms of the digital key exchanges, we have the Diffie-Hellman. I think we did talk about DH previously in our security topic. So the DH, or the Diffie-Hellman, is majorly used for exchange of the keys, the public and key exchanges. And so an IP security VPN must be bound by some of these rules, and it integrates confidentiality, integrity, authentication, and the Diffie-Hellman key exchanges, okay? And so, like we said, for the IP security protocol, we need the AH, which is the authentication headers, the ESP and the ESP plus the AH to provide the IP security protocols. To ensure confidentiality within the VPN, we must have these encryption algorithms, and we are talking about data encryption standards, the DES. We are talking about triple DES, and we're talking about the AES, the Advanced Encryption Standards, and of course the SCL as well. When we talk about integrity, to make sure that no one alters our messages as they're being transmitted over the internet, we have hashing algorithms like the MD5, the message digest 5. We have the SHA, the secure hashing algorithm, as encryption, as hashing algorithms to ensure integrity. Then in terms of the authentication, to authenticate when you want to log in to use your VPN application, we have the pre-shared key as a protocol, and we also have the RSA, which is, we also learned RSA in SSH when we say crypto key generate RSA. We always generate those authentication keys. So RSA basically refers to the letters, refer to the names of 3 guys who actually invented this algorithm. And so that refers to the Rivest, the Sharma, and Adelman. And this is our authentication protocols again. Then for the Diffie-Hellman, for key exchanges between the source and the destination devices, to ensure security within the key exchange, we have the Diffie-Hellman 1, Diffie-Hellman 2, all the way. So this is the structure of how the framework of the IP security looks like, and it needs to have all these elements so that it's considered as secure, for secure and remote access. So I think this brings us to the end of this particular concept here. I don't know if we don't have any questions, then we could meet during the next chapter, which will be